Welcome to today's tutorial. I'll be going through the 2023 past paper, which is paper B, right? It's paper B. So let's go through that. So, okay, let me close this. Okay, and then what I'm going to do is I'm going to open, what is this? Dear. So I'm going to open Dear for the UML, since we're going to start with the UML. So B cell has an integer and stimulation level presented as a real number, right? So B cell, we can assume B cell is a class, right? Because they're talking about what it has, right? But then we might not be too sure. It could be an integer, it could be, what is this, a record structure. But since this is a UML diagram, we are dealing with classes, right? So we need to create a class called B cell. So let me zoom in a bit. So we need to create a class named B cell. So I'm gonna go to my Dear, and then I'm gonna click on the class icon and then click to paste it here. And then I'm gonna double click on the, okay, it's taking its time. And then I'm gonna give it a name. So it's called B cell, right? So B cell, that's the class. And then I'm going to go to attributes, because remember with the Dear app, right? Attributes means that the variables that are part of the class. And then operations, it means the methods or the functions that are part of the class. So I'm going to start with attributes. So with attributes, and make sure when you do a UML diagrams, right, only include the things that you are required to include, right? Don't put getters and setters when they're not required. Don't put a constructor when it's not stated that you should put a construct. So it has an integer ID, right? So I need to add an attribute, and then I'm gonna call it ID like this, and then it's going to be of type int, right? And then apply. And then simulation level represented as a real number. A real number it can be anything that's written in decimal format. So it's either a double or a float. Any of those two are applicable. So I'm going to use a double for double precision. You typically use double because it's more accurate, right? So it's called stimulation level. So I'm going to add it. So click the plus button to add, and then stimulation level. And then they said it's a real number, so I'm going to make it a double. But if you have noticed that I've been making a mistake, this should be private. So I need to make it private and then make this private. But if we end up finding out that we have inheritance, right? If we end up finding out that B cell is actually a base class, we have to use protected, because this question, right, they're trying to test if you know proper UML notation. You can draw UML diagrams, right? So B cell has an integer and stimulation level as a real number. So we did declare them. And then B cell also has a collection of neighbors, right? Other B cells whose life cycle it does not manage. So that means it is a collection of neighbors. And we are not told how many neighbors are there, right? If they told us like there's exactly 10 or there's 20 neighbors, whatever, then would make it an array, because in an array in C++, it's fixed, right? We could have made it a fixed array. But since we are not told, we have to make it a dynamic array. But then we can't make it a dynamic array. Remember, with dynamic arrays, we use pointers, right? But then with pointers, what do? We manage the life cycle, right? We use the keywords new and delete. So that's life cycle management. But this question says whose life cycle it does not manage. So there shouldn't be pointers. So that means our only alternative is to make it use a vector, because a vector is still a collection, right? But then a vector, it grows. A vector is more applicable because we don't know how many neighbors are there, how many other B cells are there, right? And also we don't want to manage the life cycle. It says that it's not, the life cycle is not managed, so we can't use a pointer. So our only option that we are left with is a vector. You could also make it a list, that's fine, but then they didn't teach you lists, they taught you vectors, so we're going to make it a vector. So the name is neighbors, right? I'm going to call it neighbors. And then the data type is going to be a vector of what? B cell. Because they said it's a collection of neighbors, which is other B cells. So it's of type B cell. And then I'm done. And then I need to make it private, right? And then apply. I'm making it private because so far we don't have, or we don't know whether B cell is a base class or whatever. So far I don't have that information. So by default, I'm going to make them private. The ID and stimulation level of the B cell, they are set during creation and can be both accessed afterwards, right? One thing at a time. Let's do one thing at a time. They say the ID and stimulation levels of the B cell can be set during creation. By during creation means that the constructor, because remember the constructor, we call that the builder. That's what gets called when you create an object, right? Hence it's called a constructor. Okay, is it opening? So remember a constructor, right, is basically a builder. And this constructor gets called when you create, or another word for create is build an object, right? Which makes sense. If you want to build something, won't you call a builder? For example, you want to build a house, won't you call a builder a person who builds houses? You will, right? So hence we know that it has to be called they meant the constructor when they said during creation. When they say during destruction, you know that's the opposite of creation, which is the destructor. So I'm going to click new, and then remember the constructor has the same name as the name of the class. So it's going to be B cell, which makes sense because what other object am I building other than a B cell? I'm building a B cell, so hence the constructor will be called a B cell. So B cell, and then under parameters, right? I need to take in the parameters because they said you should take in an ID and stimulation level. You see, the ID and stimulation are set during creation. So you need to be very careful when you're working with these questions. So I'm going to pass in the ID, and then the data type is int, if you still remember. And then the next thing that I'm going to pass is the stimulation level, which is of type double, if you still remember, and then apply. And then we are done with the constructor. They also said and can both be accessed afterwards. They said accessed. So you create accessors. If they say that they can both be set or changed, then you create setters. In this case, they can both be accessed. So it's only accessing. So I need to create two accessors to get the ID and to get the stimulation level. So I'm going to call the first one get ID, which returns an integer. And then I'm going to create another one called get stimulation level, which returns a double because the stimulation level is a double. And then apply. Right. And then we are done. So we are done with this part here that I've highlighted. So now we can move on to the next. So the next one is a B cell can add or remove neighbors, right? So by add or remove neighbors, it means that we can, okay, you can add or remove neighbors. So this is the only way that I can approach this, right? Is you can add another B cell, right? Because remember, neighbors are just of type B cell. So you can add a B cell. It means that you should the function should take in a B cell. And then you can remove a neighbor. They didn't talk about things like stacks and queues you remove at the end or at the beginning. They didn't talk about any of those things. So even for removing, I must also pass in a B cell, which is the specific B cell that I want to remove from my neighbors. So that means I need to create two methods. How do you know whether it's a method or a variable? If you see the term, and if you see the word, right, it's a verb, then you know it's a function. So add, what are you doing? It's a yeah, it's an action, it's a doing word. And then remove, you are removing. Yeah, that's an action. So therefore it's going to be a function. So I need to create two methods, add and remove neighbors. And they didn't talk about returning, which makes sense. You wouldn't return anything if you're removing. So I need to create a function called add. So I want to make things simple for the assistants, right? I'm going to call it add neighbor and remove neighbor so that they know where this which question this function is answering. So add neighbor, it's going to be of type void. It's obviously going to take in a neighbor. So I'm going to pass in a neighbor, which is of type B cell, because remember what this add neighbor does. It goes to our vector, which is of type B, and then it adds to the vector. So we can actually call the pushback method for the add neighbor function. And then for the remove neighbor function, we're going to create a pop function. Okay, let me see. Okay, with regards, okay, now I see how we can right, we can, yeah, there's many. This is an open-ended question, right? You, for the remove neighbors, right, remember a vector. With a vector, you can call the pop method, right, to remove that node, or the not the node, that element in the array, in the vector. So you can, for the remove method, you can either make it take a parameter or no parameter. That's up to you, but I would suggest you take in a parameter, because if you just say remove neighbor, which exact neighbor you're removing from the vector, so you need to be specific. So I'm going to call it remove neighbor so that it's easier for the assistants to understand my code. And then it's going to take in a neighbor, right, which is of type B cell, right, and then apply. Then so far so good. And then, okay, there's quite a lot involved here. So we're done with this part. So now we're reading the next sentence. A B cell, hey, there's quite a lot of things. So a B cell has a detection operation, which accepts a list of real numbers and returns a list of real numbers. So I kind of get why you guys you're saying, okay, we need to do this 2023 past paper. It's understandable because there's quite a lot involved in this paper. So a B cell has a detection operation. At least they told you that it's a function. Remember, operation is another word for function. So in your question papers, if you see the word operation, right, it just means a method or a function. All of these words, they mean exactly the same thing. So a B cell has a detection operation. They told you it's a detection, so it has to be called detection. I don't have to specify detection. I don't have to specify what am I detecting. So they said it should return a list, right? They didn't tell you what number. So the list, there's actually a list there's something called a list inside C++, which is exactly like a vector. You declare it exactly like a vector. If you wanted to be very, very like accurate, right, you could have done this. They said you should return of a list of real numbers. By real numbers, remember we talked about that. That's a double. So I can say list of real numbers, which is a double. like this. Or you can use a vector. You can say a vector. But then I like to be very direct, right? They could they if it's a vector, they tell you. So I will use a list, right? There is a list in C++. It works exactly, it's similar to a vector. It's very similar to a vector. You could do that, and then yeah, which accepts, so this detection operation, it accepts a list of numbers and it also returns a list of numbers. So we are not done yet. We need to make it accept or a parameter, which is a list of numbers. So I'm just gonna, the name of that variable is gonna be called numbers. Its data type, remember they said it's a list of real numbers, which is a list of doubles. And then apply. Remember that you can choose a vector or a list, that's up to you. Because they just want to see whether you understand the UML notation and you can follow instructions. It literally says list. So I would just use a list. And then that's pretty much it, right? So we are done with the first class. So there's quite a lot of information for B cell. So all of this information that I've highlighted, this was information for the B cell class. So I'm done with that. And then I'm going to click OK. So there's the B cell class. I'm gonna put it there. And then I'm gonna click and add another class. And then the other class, right? So the other class, it's a classifier. So it's called classifier. So I'm gonna copy this name to make my life simpler. It's classifier and is a kind of cell, of kind of B cell, is a relationship. This is inheritance. If you remember inheritance, is a kind of B cell. So I'm gonna go here and then I'm gonna put in the name of the class classifier, and then we start with attributes. So let's see what this child class has, or this derived class has. So this derived class of B cell has a classifier type, which is an enumeration constant that is set during creation. So there's a lot going on here, right? They said a lot of things in one sentence. So let's start here. They said the classifier, which is a kind of B, so to tell you that this is inheritance, right? And then let me see, highlight selected text. So they said it's a kind of B, so all right. But then they also told you that it has a classifier type, right? By classifier type, they mean that that's the data type. It has that variable, that attribute. So I'm gonna come here and then I'm gonna click new and then I'm gonna add that attribute. So the data type is of classifier. There's a classifier type, right? If I'm not mistaken. Yeah, classifier type, which is an enumeration, right? So its name, its data type name, I'm gonna call it type. And then remember to make it private, and then apply. And then we've handled the classifier type, right? Basically declaring it as an attribute. We are done with that part, which is an enumeration, doesn't matter. This is just UML. The thing is, there's no diagram to say an enum here. So you're just gonna assume the user who's looking at your diagram, they will know that this is an enum. So just leave it as just declare it like a variable, like a normal variable. That is set, so it's a enumeration constant, right? It's a enumeration constant that is set during creation. Remember what we talked about during creation? That's a constructor. So I need to go to operations and then click new and then classifier, which is the constructor, which is because the name of the class is called classifier. So hence the name of the constructor will be called classifier, since the constructor will build a classifier. And then the parameters that it will take in is the type. I'm going to call it type, and then it's going to be classifier type, some of type classifier type, right? So we've answered the question. So up until here, we've answered that question, right? We have, except for this is a kind of B. So we haven't put the UML notation yet. But then everything else that was supposed to be declared in this first sentence here, it has been declared. We've answered everything here. And then the next sentence says a classifier performs the detection operation in its own way. So that means the detection needs to be redeclared inside your classifier class. So the detection function, it took in a list of numbers and then and returns a list of numbers. They will know that it is a polymorphic function, whatever. They'll know that. But too if you're a perfectionist, you can go back to the base class and then change this from live to virtual. You can do that. So I'll do that. It's gonna have a subtle difference. You might not even see it. So that's why we just typically don't put it. So they'll see that it's a polymorphic function by you redeclaring it in the child class. So it returns a list of doubles, which is a list of numbers, and then it also takes in a list of numbers, which is of type list of doubles, and then apply. And then there's the detection function. Since the fact that it's redeclared inside classifier class, the assistant will know, okay, this is a polymorphic function or this is a virtual function. So basically the classifier performs it in its own way. And then an N is a classifier and also performs the detection operation in its own way. So there's quite a lot going on here. So now we need to create the N class. So we are done with classifier at this point. So classifier, the function is still polymorphic, right? Meaning virtual. So I'm gonna click on virtual and then I'm gonna click apply and then okay. You can actually see, if you think about it, if you look at this function, isn't it in cursive? Sort of like cursive, right? You see, that's how you can tell that okay, this function is polymorphic. By polymorphic, it doesn't really state whether it's a pure virtual or just a virtual, but it's just a polymorphic function. So I'm gonna select it. You'll see that small difference compared to the other methods. You might not, but there is a subtle difference. So I'm gonna put this, and then underneath classifier, I'm gonna put in another class because classifier is also a base class to this N class, right? N by A double N. That's what N means. So N, that's what I mean by when I say N. So an N is a classifier and also performs the detection operation in its own way. So you see that this is the N. Okay, the N is basically, it doesn't have any other new attributes. So it only has the method. So I'm gonna go to operations. Yeah, this question was a bit tricky for people who don't pay attention to details. So this returns a list of doubles. If you don't pay attention to details, yeah, it's going to be problematic. So here, I'm going to leave this as final because there's no other class that states that this detection method is also defined within another class. So I'm just going to leave it as final there. And then it takes in a list of numbers, which is basically a list of doubles. Like I said, you can make it a vector. That's okay. You should make it a vector because, but there is something called a list in C++, and they did say a list. So I'm choosing to take that approach. So there's our class. I'll put in the UML notation after, right? So these are all three classes, right? So we are done with those. So we need to do the containment class, right? Whether it's composition or aggregation, it depends on the question. So now we're going to that containment question. So an artificial immune system, right, has A, you see, has A. So that's a containment. And there's two types of containment. There's aggregation, then there's composition. Aggregation, there is no life cycle dependence. Basically, it means that that class does not manage its life cycle. That's aggregation. Composition, there's a life cycle dependency, meaning that that class manages its life cycle. And how do you distinguish between the two? If it manages its life cycle, you have to make it a pointer. If it doesn't manage its life cycle, you don't make you omit the pointer. So here they said it is a collection of B cells whose life cycle it manages. So there's a collection, right? Remember we talked about this, and when we talked about this, when we had to come up with the vector. I use a vector there because they said its life cycle it does not manage, but we still need a way to get a list. So the only other way is using a vector or a list. You can use a vector or a list. So that's why I use the list there. In this case, it manages its life cycle, so I have to actually use a pointer to manage life cycle. I can't manage life cycle using a vector. I have to use a pointer. So I have to actually make it a pointer. So it's a collection of B cells whose life cycle it manages. So collection of B cells. So I'm gonna say name, I'm gonna call it cells, right, in plural. And they said it's a collection of B cells, so B cell pointer, because there's a life cycle management, and then private, and then apply. I hope I don't forget to make the attributes inside B cell protected, because now B cell is a base class. Remember, they need to see that you understand UML notation. You know when to make things protected, you know when to make them private, you know when to make them public, things like that. Even though it's just 5 marks, all those 5 marks, they go in all those places. So whose life cycle it manages? So this part we've answered, right? It has a collection of B cells whose life cycle it manages. So that's composition, which is going to be the shaded in diamond, right? And then it also has an NAT, a clonal rate and mutation rate, which are all real numbers. In this question, there's a lot to write, only for 5 marks. But yeah, that's computer science 1B. So it has NAT, clonal rate. So let's declare them one at a time. All of these are attributes. How did I know that these are attributes? Because they are nouns, right? Clonal rate, mutation rate. You see, these are not verbs. They are nouns. So that's how I know. That's how I knew that they had to be variables or attributes, in which all of them are of type double because it's real numbers. So NAT, right, and then double, and then private, don't forget, and then apply. And then we need to have a clonal rate, which is the rate at which you are cloning. I don't know what they're cloning, but yeah. And then mutation rate, the rate at which that thing is mutating, which would be a double, and then private, then apply. But then there's also more information, right? So far what I've declared, what I've done, it's only this part. I've only made them available, right, by declaring them. But then there's the end. We need to we need to continuously read what's there and assert when the artificial immune system is created. What does that mean? It's when the constructor is called. That's what it means. Because when the artificial immune system is created, when is it created? When the constructor or the builder builds the object. So that means I need to create a constructor. As you can see that I'm not putting a lot of things. I'm only answering what I'm told to answer. Don't put extra things. Don't put accessors, and setters, all those things. Don't, when they're not necessary. They didn't tell you, don't put them. So they are set during, so I need to pass all of them as parameters here. So NAT, clonal rate, and then what's the other one? Mutation rate, which is the rate at which that being is mutating, whatever. Okay, or that artificial immune system, it's mutating. And then that's pretty much everything we need here. And then let's see what's left. The artificial immune system delegates its detection operation to its collection of B cells. So we are doing a delegation here, right? These people, this question was not playing around. I don't want to lie to y'all. This question was not playing around. And this time around, it's vice versa. Usually, you have it inside the UJ image class, in which delegates its own draw method, whatever that method is, right? Now it's vice versa. It's that other class which delegates to the base class. So it's vice versa. So it delegates a what's the function? Its detection operation to its collection of B cells. So we did have a detection method, if you remember. Where is it? Where's the detection method? Collection of neighbors, a set, however, a B cell is a detection, yeah. So a B cell is a detection operation which accepts a list of numbers and returns a list of real numbers. But remember when you're delegating, right? The class that's delegating its own method, that function should not take in any parameters. It can return whatever it's supposed to return, but it shouldn't take in any parameters if you remember very well. If you remember, let me make this illustration because I feel like a lot of you guys won't understand. But if you remember, we had this class, right? Class, let's say UJ image. Not UJ image, let me say UJ shape. Right? We had this UJ shape class, which had a public method, right? Called draw. Right? And then it delegated to this the class that draws, right? So let's say we have a draw. Let's say the UJ shape has a draw, has a UJ draw, right? Pointer, right? Underscore draw, which it delegates to draw function or to the draw class. You see that usually we don't have the class, the function is empty. Then when we implement, when you implement, remember say UJ shape and then draw method. And then this should return a void, obviously. And then when we delegate, we just use that draw underscore draw. And then we dereference and then use the dot notation to access the method within that class called draw. But then I need to pass myself that object and then dereference because this passes an address. I don't want an address. I want the actual object. So I dereference or I point to that address to pass the object. But then this needed to match. Remember, if you're calling a function like this called draw, I'm passing this. What is this? It's UJ shape, right? So that means this within the UJ draw class, right? We needed to have something like this. So public, we still have that. We need to have that draw method, which is the draw, right? But it needs to take in a UJ shape, right? And you can take the UJ shape by reference, whatever, but then it takes in a UJ shape at the end of the day. So that's why we dereference because we need to pass that UJ shape there. But in our case, we are not passing a shape one thing, we're passing that list. But then the person who's delegating usually has a function with no parameters, as you can see. UJ shape is the one that's delegating in the scenario. In our case, uh, in our case, the artificial immune system class is the one that's delegating. So that means we're going to decay the same way as this detection method inside B cell, but the only difference is that inside artificial immune system, it won't take in any parameters. Since artificial immune system is the one that's delegating. Remember the detection method, right? Let me go back here. Remember the detection method inside B cell. You see, it takes in a list of numbers. we already have okay, text in a list of numbers. I think we already have some list here. Okay, it's a list of B cells, whatever. But then yeah, it's fine. Yeah, it's a list of B cells. It's fine. It's actually very complicated than what I was thinking. But yeah, just keep in mind that the class that delegates it that for that you need to declare that same function, right? So with the exact same name, detection, and it's supposed to return a list of doubles, right? Because if you check here, the detection method within the B cell, it returns a list of doubles. But like I said, if this class is the one that's delegating, that method shouldn't take in any parameters. Why? Because under attributes, we actually have a reference to all the cells. So we can actually get the list, which is that neighbors vector. We can get that list via this private cells attribute. So I don't need to pass it as a parameter. So I'm going to apply and then, okay, and then I'm done. Yeah, that's pretty much everything. So now let's put in the UML notation. So I'm going to come here and then this will be composition. Why composition? Because this life cycle is managed by the B cell array. Its life cycle is being managed by artificial immune system. So when you leave it like this empty, it represents aggregation. You need to shade it in or color it in. Since you're writing it on a piece of paper, just color it in. In my case, I need to double click it and then go to type, which represents the type of containment or association. I'm going to choose composition and then apply and then click OK. But then it's vice versa. It's wrong. Why is it wrong? Because this is not inside here. This is the one that's inside here. So therefore, I can easily change this. I can just double click here and then change the direction to go in the opposite. So instead of from A to B, you should go from B to A. And then I click apply, and then I click OK. Why did I do that? Because B cell is the one that is part of this class. That's why I did that. And then we need to show inheritance. So this generalization, it's just the triangle. Don't shade the triangle in, or else you're not representing inheritance. Okay, so there we go. And then I click it again and then put it here. So there we go. So that's pretty much the full diagram. Where I declared a list, you can make it a vector. That's fine. But I just use the list because I know a list exists inside C++. And the question actually says list. So yeah. So this question was actually not easy if you didn't know what you're doing. So yeah, it's very tricky. If this is the level, yeah, yalla cooked. But if you study, you're gonna be fine. So I'm gonna click on file and then I'm gonna export the diagram. Let me put it on desktop and then I'm gonna name it it's question 1 2023 paper, which is the UML, and then save. So let me just double click. Let me just double check if it's there. I'm gonna double click and then there's the diagram. So yeah, everything is there. So that's pretty much question 1. Even though it kind of looks like it's short, or it's 5 marks. Since it's 5 marks, you're like, it's short, it won't take time. There's a lot of understanding that takes place. You need to understand a lot of things. Okay, it's actually question 1.1. So I'm gonna go to my notepad and then I'm gonna delete everything. And then I'm gonna save this on the desktop, and then I'm going to save this as 2023 CSC 01B1 exam memo paper B, right? And then I'm gonna make it just a normal text file. Why is it doing this? Yeah, normal text file. Okay. So I'm gonna save it as a normal text file, but then from time to time I want it to highlight that when it sees C++ code. So let's go back to the question paper. So let me connect my charger before this thing starts complaining. Okay, so let's continue. So A dash is a blueprint of an object-oriented data type. So what is a blueprint? A blueprint is basically a class, right? Remember what we talked about, the class, with classes. A blueprint, a class has, so the answer here is going to be A, if I'm not mistaken. Yeah, which is capital A. So A, because remember when you're making an object, you need to have two things. Before you, okay, any object is, it always has two things. There's the plan, then there's the actual object. So for example, when you build a house, you first have a blueprint or a plan, right? Hopefully you have a plan, because you can't just start building a house and then you go with the flow. That it doesn't work like that. You need to plan it first, then you after planning it, then you build, you call the builders, which is the constructors in our case, to build the actual object. So when it comes to templates or a blueprint, the answer is going to be class, right? So that's class, and then which is A. And then 1.3, which object-oriented principle allows us to avoid the slicing problem? Okay, this is, let me see. Remember the, if I recall, a slicing problem. Okay, no, that's not. What is it called? A slicing. If I is it the slicing of the diamond problem? I think I'm thinking about the diamond problem. So let me just. I totally forgot. Don't want to lie to you. Totally forgot what slicing problem means. Multiple matches for slicing include. When the challenge. Okay, I totally forgot what slicing problem means. I'm thinking about, do you know when you have when you have a class that inherits from multiple base classes? That's what I'm thinking. So let's see. The slicing problem typically refers to a few different concepts. You see, there's multiple definitions for this thing. So depending on the context, here are some list of interpretations. An array or list slicing. Slicing problems involves determining the correct set. Nah, that's not it. In software engineering, program slicing refers to extracting parts of code relevant to a particular computation or slice of the program. A slicing problem in this context may involve isolating the portion of code that affects or depends on a specific variable outcome. I don't know if it's not even clear what slicing problem they're talking about here. But let me see. But is it the diamond problem or the slicing problem? I can't recall. I honestly can't recall. Yeah, the slicing problem, totally forgot that. We'll get back to it. So if 1.4, a function template that is a friend of a class template. How are they phrasing this? A function template, right? We get that. that is a friend of a class. Okay. Okay, so it's a templated function that is part of a class, which is also a template class, or basically a generic class, does not use the same type parameter as the class template. It depends. It depends. So I'm not sure if this should be the answer, but it depends. For example, remember function templates, right? Let me think about it. Function templates. Yeah, it depends. For example, when you have operator overloading, so I'm not it does not use, let me see, it does, okay, it does not use the same time parameter. False. Okay, we choose false, but it could be this, because why am I saying so? Remember, we had when you had the friend function, remember, oh, they said friend. Okay, I see. That was the keyword. They said a friend function. Okay, so it's true. So that's the only time is going to have a different type parameter. So what do they mean by type parameter? This is what they mean. So if you have a class, okay, before I have that, you have template, type name t, and then you have a class, let's say an image, let's say a ppm image class, right? To make a ppm image, and then public, right? So you have public. When you have a friend function, right? They say when you're doing operator overloading, so friend operator like this, right? And then since it's inserting into the output stream, it's going to take in a standard output stream by reference, and it's going to return that standard output by reference. But if remember that if ppm image is generic, we need to put in type T here, right? And say obj image. That's how it works, because pp image is what? Templated, meaning it's generic. Everywhere where we use this type, we need to pass in the type within the anchor brackets, right? So what happens with friend functions, right? Remember, it's a friend. It's not actually part of the class. And if you remember the textbook, friend functions should not be part of public or private. It should just be at the top, like this, according to the textbook that you guys are supposed to read. I've read that textbook on a lot of chapters there. So you're supposed to declare it at the top. Don't put it under public, don't put it under private, which makes sense because it's just a friend. It's not part of the class, right? So since it's not a part of the class, you can use T because this T is referring to everything that's part of class image. So therefore, you have to use its own, give it its own template name. So type name, let's say T1 or X, whatever you want to call it. Then you have to say T1 here, right? So this is what they mean. So obviously, you see that a friend function, as long as it has a friend keyword, it has its own template parameter. You see that is T1 instead of T. So the answer will be true. So 1.3, I said we'll come back to 1.3. So let me see. 1.4 the answer is going to be true. Okay, go back here. So the answer is going to be true. That's 1.4. So let me see pro in programming. Let's see. So slicing is when you assign an object or a derived class to an instance of a base class, thereby losing part of the information. Oh, so basically slicing. Why do they use? Okay, that's object slicing. As I'm gonna assume that's what slicing is. I don't know The slicing focuses on the number of entities that exist within a particular. So let me check here. The slicing problem is a thought experiment that raises questions for substrate neutral computational theories of consciousness. This is this is someone's thesis. That's not. But I'm just gonna assume that slicing is what they're talking about here when they say slicing occurs on an object of a super. Yeah. Okay. So basically, I understand. In for those doing informatics, slicing problem, I don't know why they like to use big terms. Slicing problems is basically downcasting. That's literally what they're talking about. Slicing problem, it's downcasting. And what do you do to avoid that? So what object-oriented principle allows us to avoid downcasting? So why is downcasting a problem? Downcasting is a problem because you're going to lose. Is it downcasting or upcasting? You see now, but the thing is downcasting, not upcasting. When an object of a subclass type is copied to an object of a superclass type, the superclass type will not have. Oh, it's upcasting. It's not downcasting. It's upcasting. So upcasting, right? It's a problem. Why is it a problem? So this is going to be quite a long explanation, but it's going to be worth it. So I'm going to create a new diagram, then create, and then I'm going to call it slicing problem. So slicing problem is just upcasting. I don't know why they couldn't just use those terms, but this is what they mean. So upcasting, let me think. If you have, mm, okay, it's fine. I'll just make a class. Okay, okay, it's fine. Let me just put it here. So upcasting, this is what upcasting actually means, right? It means that you're converting an instance or an object of the subtype to be the type of what is this? To be the type of your base class, right? That's pretty much what you're doing. So for example, if I have UJ shape, right? And then I go down here and then I stretch this out, then copy, paste it here, and then call this UJ circle, right? This will obviously inherit from this class, right? So I don't have to do the notation or whatever, but just you know that this is inheritance. So what they're talking about is that if you have an object of type UJ circle and you cast it to be the type of UJ shape, you see that you can imagine this is a ladder, right? Imagine you're climbing up, right? But then since that's actually not climbing, it's actually called casting or converting. But you're casting in what direction? Upwards. So that'll be upcasting, right? In computer science 1B, they call it the slicing problem. They're using like proper English, but it just means upcasting. What is the problem with upcasting? So here's the problem. So if inside your base class you have, let's say, I'm just gonna put it on the side here, but then just know this is a method. So inside here you have your draw method, right? Just here by the corner, right? Just imagine that's a draw method. So you're gonna have a draw method, and then UJ circle has its own extra piece of data, right? So I'm gonna copy this and then I'm gonna put it here. Let's say the UJ circle has a radius, right? Because not all shapes have radiuses, so I can't put radius within the UJ shape class. So if I have an instance, or basically a variable of type uj circle, and I have a variable of type uj shape, and I try to store uj circle into uj shape, it is allowed, right? It is allowed. The problem with that is that you lose certain things. So I won't have access to radius, because if this is casted or converted to uj shape, that means I lose radius, because uj shape does not store radius. Do you see radius within uj shape? Nope. So that's what we call the slicing problem. So if you have uj shape, this is what I mean, uj shape like this, and then you have uj circle like that, and then you say shape is equals to a circle. This now introduces the slicing problem, right? Why slicing? Which makes sense if you think about it. Slicing, you're cutting it, right? Remember when you slice something, when you get a slice of bread, how did they get a slice of bread? They cut the bread, right? That means some of the bread has gone missing, right? So imagine you bought bread that's not sliced, and then you cut it in half, and then you take the half. That means some portion of the bread has been taken away. So it has been sliced, it has been reduced, which makes sense because if circle has a radius and I try to save it inside shape, what C++ does, right? This will be automatic casting. It gets converted automatically. Why? Because each subtype is of its superclass type. What does that mean? A circle is a shape. So therefore, this is a valid operation. So since this is a valid operation, C++ will cast, right? Behind the scenes, you can imagine something like this. It'll cast this to a UJ shape, and then circle. So it'll cast it to a UJ shape behind the scenes. And this will be done automatically. Another word for that, it's called implicit casting. Like I said, they like to use fancy words. Implicit just means automatic. Imagine you have an automatic car, right? You don't have to change gears. You just put it in D, which means drive. You put it in P, which means parking. That's an automatic car, right? And then explicit, that's manual. Imagine a manual car. So explicit, or another word for it, it's manual casting. That means you manually have to cast. But since this is allowed, why is this allowed? Because what's on the right hand side is what's on the left hand side. So what is on the right hand side? It's a circle. So circle is what is on the right and what is on the left hand side? It's shape. So circle is a shape. So therefore implicit casting can take place. But when you cast, what's going to happen, like the slicing problem, it introduces the slicing problem. We lose certain things that were stored inside this circle object. Since circle object has its own extra information like the radius, so the radius gets lost. We lose the radius. So their question here is, what object-oriented principle, right, allows us to avoid the slicing problem? What principle can we apply to avoid the slicing problem? There's quite a lot enlisted here, right? Basically, their question is, what can we do to avoid this issue of it losing information when you cast it, when it gets casted or converted from one type to another? And then remember, casting, it just means converting to another type. That's the term casting. That's what it means. It means you just convert to another type. So what the question is, how do we fix this? Right? How do we fix that from this thing of losing information if you're casting from the subtype or the subclass to a superclass? basically converting the child to a parent type. How do you avoid how what object-oriented principle allows us to avoid all of that? There's a lot involved here. Let's try to do a process of elimination, right? Inheritance, you can't really say it solves the problem because we're already inheriting, right? So this can be it. And then things like generics, I don't know how generics will help in any way here, because generics, it just helps us to take in any type. So now we are left with three: composition, aggregation, and polymorphism. But I don't know how aggregation will help us solve this in any way, because that's aggregation. It's just, it wouldn't make sense. Remember, this is your problem. You have a shape and a circle. You can't say a shape has a circle. If you get what I'm saying, you can't do that. So composition is out, aggregation is out. So the only one that makes sense is polymorphism, right? Which is true, which is correct, because polymorphism will allow us to redefine, right? That, to implement it differently. And when it's implemented differently, if you remember your practicals, they did emphasize on polymorphism. So this will be D, right? Is it D, polymorphism? Yeah. So remember polymorphism. If I have the draw, remember what polymorphism is. I have the draw method here. It's going to be redefined within the circle shape. And then circle will return an answer, right? So even if I cast it to UJ shape, the draw method has the answer of circle, and of which circle use the A radius to calculate to draw that shape. So you see that I do not lose anything when I convert from a UJ circle to a UJ shape. I do not lose anything with polymorphism. So that's pretty much how you can solve that. So I'm gonna do this so that when you look at this, you don't get confused. So this would be our answer. A function template that is a friend. Yeah, we did solve this. The answer is true because they said it's a friend. You see, the main, if they didn't put this, right, they might trick you and not put it and ask the very exact same question and not put the friend keyword. If they don't put the friend keyword, this will be false because they use the same type by default. But the moment it's a friend, that means it's not part of the class. That means you must treat it as a function on its own. So therefore, you need to give it its own template type or parameter type. And then let's go to 1.5. Yeah, that was quite a lot of explaining, but at least now you guys understand. The most appropriate way to store numerical constants that are in increasing chronological order is by using this is very straightforward, numerical constants, numbers. Static is, you can't choose static. Static just means things are shared, so that's totally irrelevant. A struct can store anything, it doesn't store, it's not meant for constants. An array, it's not meant for constants because you can change the values. You get the difference, you can change the values. Class is for objects. So that's totally not the answer there. So the answer is supposed to be enum, because with enum, it's like a unique way to represent constants that are in increasing chronological order. So this will be B. It's going to be a constant, and then 1.6 Q1 is a B1, right? Yeah, this is the diamond problem that I was told. I think it's going to be diamond. Remember diamond, right? For those who don't know diamond. Diamond is basically when you have more than one class that serves as a base class for that child class. So what do I mean by that, right? So this is what it means. So let me make an example of diamond problem, and I want you to look at it closely and see that it kind of looks like a diamond shape. So I'm gonna delete this, and then I'm gonna have 1, 2, 3, and then I'm gonna put it here. Um, okay, so let me do this. So let me minimize it again. So yeah, so we're gonna have UJ shape. I'm not gonna waste time changing colors. So imagine this is like your grandparents, right? I like to use this example because it's simpler to come with that example. So I'm gonna change this, put it here. So imagine this is remember this is how everything works, right? Your parents have their parents, right? Of which they will be your grandparents. So hence I'm gonna call these classes grandparents. So you have grandparents here like this, right? Which gave birth to your, let's say this is your father, and then let's say this is your mother over here. And then they gave birth to you, to the little rascal, which is you. And then the 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 little rascal, which is you, this is now you. So this is you here, the little rascal. So this is you here, and then let's see the diamond problem. So obviously this one inherits from this, right? This father's parents, which are your grandparents. Hence, to be honest, this is supposed to be parents, right? But then I'll use grandparents so that you can kind of get the picture. So your mother also has her own parents, and then you inherited from both. For those who did life science, they know this better. So, or biology for those who don't know. But yeah, you see, so now you are inheriting from multiple classes, right? You have multiple base classes. That's what we call the diamond problem. Why is this the diamond problem? So let me try to introduce different shapes. Let me use different arrows, right? So that you kind of get the whole diamond issue where this why are they saying diamond? So if you take this, come on, and you draw it in this way, right? Um, okay, this is not like this, right? And then like this, and then like this, right? So this is you, and then I'm gonna copy, and then I'm gonna put it down there, like this, right? Don't worry, it will make sense once I'm done drawing it. And then I'm gonna take this and put it here, and then I'm gonna rotate, put it here, right? So you can imagine you're inheriting, right? I'm just putting this arrow so that I can kind of make you guys see the whole diamond thing. Where are they getting the whole diamond thingy? And then right here, and then put it a bit on the top. And then put this here, and then shift this to the top a bit, and then there we go. So You see that it kind of shapes like a diamond. You see, it goes like this, right? It's like it's in a diamond. Because remember, this is a diamond, right? You see, this is diamond. It's like this. Doesn't this look like a diamond? So that's why they call it the diamond problem. So when you have more than one base class, U has actually four base classes because it is this and this and this and this. So multiple base classes, right? Because it's inheriting on this side. And okay, it's not really a problem with these classes at the top. The only problem is actually here. You see here, this you are inheriting from two classes at the same time. So that introduces the diamond problem. So that diamond problem, how do we solve it? So you see that they say QB is a Q1, right? And then QB is also a Q1A. Yeah, what problem can this create? So they're saying Q1B is a Q1, and then Q1B is also a Q1A, which is fine because it's still inheriting from more than one base class. So what do they mean by Q1 is this, Q1 is that? This is what they mean. So let me draw it and put it in programming, right? In diagram format. I won't necessarily do UML, but just to demonstrate. So this is Q1, right? And then we're going to have Q1B at the bottom, Q1B at the bottom. And then we also have Q1A. So I need to have Q1A, Q1A here, Q1A. Don't mind the capitalization, it's still Q1. And then I'm going to do this and then this. So what they're saying here, right, is that Q1B is a Q1, meaning that it inherits from Q1. So it's this, it inherits from this. Q1B is also a Q1A, meaning that it inherits from Q1A. You see that now I'm inheriting in two classes at the same time. This is now what is called the diamond problem. So they're asking you what problem can this create in C++? It's called the diamond problem. So the answer is going to be D. And then, yeah, even though I take time to explain some of these things, but it kind of makes sense. You need to see. You need to understand what's going on. So 1.7. Okay, 1.7. What are they talking about? Class, action, agent. Okay, so consider the following code segment. Identify any three concepts that are related to object-oriented programming. So any three. So they gave you an example, line 1, information hiding, right? But it needs to be related to OOP, right? By OOP, what does that mean? Composition, aggregation, delegation, inheritance, all of those things, they're related to OOP. So let's scroll down. Okay, here they did omit the code. I think it didn't really matter. The code doesn't really matter. What matters is understanding the concept. Line 14 and line 15, if you remember this is a pure virtual function, right? So this is question 1.7. So you need to specify the line number. You see, they told you that e.g. line 1, this is the concept. So I'm going to specify the line number. So you can choose line 14 or 15, doesn't really matter. Choose one. Don't say both. So I'll just write it as line 14 or 15. It's a pure virtual function, right? And then this is a pure virtual function. And then let's see. I don't know about world state, right? Or world state is an enum. Okay, that's fine. Okay, that's fine. So this is a pure virtual function. And then let me see. Okay, that's fine. Yeah, it's a pure virtual function. I'm just gonna leave it at that and just call it a pure virtual function. And we have line 19. And you need to be very careful with analyzing these things because I almost missed this. You see, it's of type action, right? So what is action? It's another class. So we have a class within another class. It's either composition or aggregation. But here, do you see any pointers? If there are no pointers, it's aggregation because you're not managing the life cycle. So line 19. So line 19, that's aggregation, right? I think you might get 1 mark if you say containment. You might not get the full marks, but okay, you might get half a mark. So that's that. And then here is what we call inheritance or public inheritance in full. But then you can just write it as inheritance. So line 22, I know that OOP concept. It's called inheritance. So inheritance. You could also say line 24 and just say that's a virtual function because that's just a virtual function, right? This one over here is just it's a pure virtual function. Those are two different things. Pure virtual function and the virtual functions are two different things, but it's basically the same thing. It's basically the same thing. So yeah, or you can say, what is this? You can also say, let me see, polymorphism, right? You can say polymorphism. So you can say line 24, we say this demonstrates polymorphism. Why? Because not really in polymorphism, but it is actually polymorphism in a way. But I would rather just stick to pure virtual function. Just say that's a pure virtual function. Leave it at that. Don't try to do a lot of things. So that's pretty much. They said how many? Three concepts, right? They said three. And they said any, right? So you can choose any that you feel like. And then here, line 30, this is called instantiation, right? You're instantiating an object. So it's called instantiation. But here, okay, there is instantiating, right? But there's also something else here. There's something else. Yeah, there is something else here. But then it's fine. But then let's not get into those details. But this is instantiation. So I can also put that there for those who need extra points. So line 30, you can say instantiation, or you can say instantiating an object. But I'll call it instantiation and leave it like that. And then that's pretty much it. Okay, how long is the video now? Okay, there's still a lot of time. So using namespace standard. Okay, what are we supposed to do? Consider the following code segment below. What are the three member functions that are not necessary? Right? They're saying what three member functions are not necessary. They want you to actually really think here. So let's see. What member functions are not necessary? And I want you to name three. So we do know, wait, well, they said that are not necessary. We do know this thing, right? Rectangle, the copy constructor should always be there. The destructor should always be there. Okay, they say that they're not necessary, but yeah, technically you can say that the destructor is not necessary, right? Because I don't have a pointer. I'm not deleting any memory. It's not necessary. By necessary, right? The term by necessary, it just means it's not a necessity, right? You don't necessarily have to put it there, right? It's not like they said which functions are not supposed to be there. That would be a different question. I would say number one, the destructor is not necessary because there's no pointer. There's no memory management, right? There's no managing memory here. It's not necessary. And then let me see if I have this. The assignment operator is fine. Let me see the assignment operator. Yeah, the assignment operator, I think it's fine. As for the get length and get width, let me see. This is a tricky question. So let me see. The distractor, right? It's not really necessary, right? But I think C++ won't allow you to, yeah, it won't. Yeah, it needs to, even if it's empty, it needs to be there. So it's necessary, right? The copy, so between these two things, right? We have the assignment operator and the copy construct, which basically do the same thing. If I was the one to writing this class, the copy constructor is unnecessary because we have this copy construct, we have this assignment operator here. So it's basically doing the same thing, even though they always say that it's the big three, right? It needs to be there. So the big three, it's the copy constructor, destructor, and assignment operator. But I don't see, because what's the point of doing a shallow copy when you already have an assignment operator that does a deep copy, right? The thing is, they didn't. This question is like very open-ended. They didn't give you like any context, like to say, okay, what about in this scenario? Or for example, if I'm inheriting from this class, or this is going to be a base class for this, is it necessary? Or which functions are not necessary? If they'd been that specific, right? Because I don't even know whether the user is supposed to access these functions, these values. So I don't know if that's a necessity, because it depends on the problem statement. So the question, the way they flagged the question, phrase the question, it's a bit ambiguous, to be honest with you. You would have to raise your hand and ask the lecturer, in what context do you say what three member functions that are not necessary? But the ones that I would say they're, let me see. One thing that I can tell here, right? So we need to really think about this thing in our own way. But this is very vague. This is not okay. Questions should be direct. A rectangle, the parameterless constructor is not necessary. Why am I saying it's not necessary? Because we don't have constants. If we had constants, right, this would be necessary because we have constants. And you see that there's no constants here. So number one would be the parameterless constructor. That's not necessary. So 1.8 parameter less constructor. The parameter less constructor is not necessary. And then what else is not necessary? The parameterize is necessary because we need to initialize this since they are private, so that's a must. Copy construct in the other way, no, that's not really necessary. Because remember when is the okay it is necessary. Okay, it's fine, it's necessary. Because I'm thinking about it, if you say uj image and then you have image 2 and then you say there's different, okay, let's say this, right? You have uj image 2 and then you say image is equals to image 2. This will call the copy constructor, so it needs to be there, it's necessary. This line of code, when you use the assignment operator, and basically you do two things in one line. You declare that object and assign it to another object. This will call the copy constructor. Copy constructor. So copy constructor is necessary. And then when we assign an object, right, image 1 to image 2, this will call the assignment operator. Assignment operator. So that'll be necessary. So then the destructors, to be honest, to be honest, the destructor isn't really necessary because we don't have pointers. It's just that C++ tends to have issues when you don't put it. It'll be like, where's the destruct? But it's not really a necessity. But according to C++, it's a necessity, so we're gonna put it there. So this is fine. These two are fine. Okay, these three are fine. So now we are left with these three. In this context, I do not know whether you're supposed to get the length or set the length. I do not know. So I would just say they're not necessary. Like I said, context is very important. Give us an example. Like if you have this, then that. They didn't talk about it. So I would just say get length function and then get width function. Right. I don't know what answers he chose, your lecturer chose, but there's no context here. Assignment operator is also not really a necessity. You could just choose these three, but then assignment operator, the thing is, sometimes you want to perform a deep copy, and more often than not, you're going to perform deep copies. So the assignment is a necessity. So the only ones that I'm seeing is the get length and get width and the parameterless constructor. The parameterless constructor, the reason why I chose it is that there's no constants here, so it's not necessary since there are no constants defined. If we use the parameterless constructor, what are we going to set the length and width? You see, becomes a problem. So it's not necessary. The get length and get width, the problem is not specified whether you should be able to get the length or set the length. It's not specified, it's not specific. So yeah, we're just gonna leave it like that. Remember the operator, right? The assignment operator. You might be like, well, what about when I'm copying from this object? Remember, it's a member function. So this obj right hand side can access these private member variables. So these two are not necessary in that context. So I hope the answers match, but you just have to confirm with your lecturer. So name the data structure that is being described by the following statement. The last element, meaning the last thing, right, to be inserted into the data structure is the last element that can be removed. These people are trying to trick your brains. Remember stacks and queues. Queues is basically like a queue, like the normal queue like the Q's at what is this? The Q's at what is this? Capitec and blah blah and ShopRite, whatever, those queues that you be in, these are the queues, right? So imagine this is the first person, right, in the queue. This is number two. This is number three. So obviously, the queue, it follows the first come, first serve philosophy, which basically is called first FIFO or FIFO, right? Which is FIFO, which just stands for first in, first out, which just means that the first person to be in the queue is the first person to leave the queue. So obviously, if that's the case, that means the last person who was in the queue will be the last person to leave the queue. That's basically what they're telling you here. The last element to be inserted into the data structure is the last element that can be removed, which can only be a queue. A stack, remember, a stack is like a stack of plates, right? Like putting plates on top of each other. That's a stack. Obviously, if you have multiple plates, some people be like, wow, they can argue that yeah, you can take the plate at the bottom by lifting all of the plates up and only take the one at the bottom. Well, imagine you have 5,000 plates piled up and you want to take that plate that's at the bottom. You must always take at the top, meaning the last one that was inserted is the first one to leave, which is different here because it says the last one that was inserted should be the last element, not the first one to be removed. If they said the first one to be removed, then it would have been a stack. In this case, it's a queue. So 1.9 is going to be a queue, right? And then name the object-oriented concept described, um, being described. So a B cell is an antibody. You have to know biology here. I don't know it. I didn't do it in high school. So I don't know why they like to use weird examples. This is not fair because not everyone did biology in high school. So you shouldn't know this. Even those who did, they might not necessarily know it, but then those some do know. I don't know whether it was taught or not. But a B cell is an antibody. Is a In this case, it's you're lucky because they use an is a. What if they had said has a? That's when it becomes a serious problem. So in this case, it's just an is a relationship. So remember, is a, it's inheritance. A fruit, an apple is a fruit. So it's inheritance. So one or I is going to be inheritance. If they'd chosen like things like composition or aggregation, that's when it becomes a problem. So in this case, it's not going to be a problem. So an antigen stimulates a B cell, right? What's that word? Yeah, okay, I think I remember. Is it association? Yeah, I think it's association. An antigen stimulates a B cell. They're just association. They're just associated to each other, right? There's no deep relationship, right? I think this is is it general association or just association? You just double check on the slides. Yeah, it's neither composition nor aggregation nor inheritance. So it can only be association. They're just associated to each other. And then a body has an immune system. This is a better example. If they had used a different example, we're gonna have beef because everyone needs to be able to understand the problem. So a body, which is your body, has an immune system. Can the immune system exist outside of your body? Nope. So the immune system depends on your body's existence. So there's a life cycle dependence. So therefore, that's going to be composition. They'll still give you marks, right? But then you get half a mark if you wrote aggregation instead of composition. But this should be composition. And then question 2. So question 2, we'll just quickly go through it. Yeah, I'll just quickly go through question 2. Let me see. How long is the video now? So let me see. Let me quickly go to question 2. Yeah, let me go to question 2 because it's a bit short. So complete the following code in which a generic storage 2D class acts as a container for one-dimensional data type of type T. So it acts as a container, right, for a one-dimensional data type of type T. So it's a generic class, right? So store your answers from A to J. They did tell you, so 2.1, I need to store my answers from A to J. So 2.1, A, B, C, D, E, F, E, F, H, I, J. So let's answer the questions. So let's see. So template type name. So here you get there's two answers here. You can say class, like this class keyword, or you can say type name. That's how the reason why we choose type name, because it's easier to not confuse. So you can say type name or class. There's two answers there. And then let's see. Yeah, so you see the parameterless constructor is necessary here because we have constants. So that's why I said in the previous question, it's not necessary in that instance because we had constants, right? We didn't have constants, but here it's necessary since we have the constants. So class name field. So here const field b parameter b and then ampersand. So something is missing here. What exactly is missing? Remember, class field, it's generic, meaning it's templated. So every time you use field, you need to put in those anchor brackets and pass in this type called T. So that's what's missing here. So it's field of type T. So you only put the thing that's missing. So the only thing that's missing is, excuse me, it's less than and then T and then greater than. That's the only thing that's missing there. Of which they did put it here. So if you have common sense, this is a question that you cannot get 0 in. Or you cannot get, there's no way you can fail to get a total if you have common sense. So let's see. So this is, now we go to C. So C, we see that, no pun intended, we see that field const, it returns a field, and then we have an equal, and then it looks exactly like what? The copy constructor. So it looks exactly like the copy constructor. So anything that, remember, anything that looks like a copy constructor that is an equal sign, it's we're overloading the assignment operator. So when you overload an operator, you use the operator keyword followed by the actual operator you're overloading. So in this case, it means that we are missing the operator keyword because we already have the equal sign, we already have the parameter. The only thing that's missing at C, it's the operator keyword. So I'm gonna say operator because that's the only thing that's missing there. And then the friend function, and remember, you use a different type name here. They literally said blah. Why did they shade it off if they said blah? Because you see, you can actually see what's there. So template type name, right? This is type name. They shaded it out because They didn't want to give you the answer for here. So what's missing here? We have the friend keyword, and then we have this, and then we have the less than. And then here, the answer that you wrote in C is the same answer here. So that means this is an operator. And remember, we talked about the streamization operator. It takes in the OStream object and also takes in the object. But something seems to be missing here. What exactly is missing? And they also omitted it here, right? Which is just the answer for D, which is here. So the only thing that's missing is for us to specify this is part of the standard namespace. If you're not sure, you can look at the header file. Do you see using namespace standard here? Nope, it's not there. So that means you need to fully qualify anything that's part of the standard namespace. They did that on purpose. So you need to say standard std : right? That's what's missing there. So I had to specify that the OStream is part of the standard namespace, since you didn't say using namespace std. So now we go to E. So what's E? E is still the same answer, because remember what I said, field is templated. So you need to pass in that type parameter T. So the answer is the same for B and E. They do that on purpose. Why do they do that on purpose? You ask yourself, well, something is not right. These answers are the same. No, something is not right. Let me change it. You see, the moment you do that, they're trying to make you doubt yourself. If you know that's the answer, move on. And then here, this is the answer for C, which is operator. So that's fine. We'll leave that's not what we're supposed to answer. So here it's F. So we're supposed to return something, but we don't know what, right? We're supposed to return something, but we're not sure what. And then this is an operator. Remember, this is an operator because if I highlight this is the answer for C. What was the answer for C here? It was operator. So we know this is an operator. That's supposed to return, and we have X, Y, and Z, which is the X length, Y length, and Z length. So which is basically G. So we're accessing points. But what are points? What type is point? So point is basically, let me see. This is when you have to go back and see the additional information that you're given at the top. Complete the following code in which a generic storage2D class acts as a container for a one-dimensional data of type T. So that's telling you that the generic storage2D class, right, it acts as a container of a one-dimensional type, right? So we have to use it somewhere. Okay, so what is this? Yes, the answer for B. No, that's not the answer for B, but that's not important. So now the question is, what do we do here? So let's scroll down and see field.emp, blah, blah, blah. Okay, that's fine. Yeah, so it's supposed to be, remember it's of type T, right? So we actually have to, you can go to G to answer the question, that's up to you, but I'm not gonna go there because I know that this is a templated class, right? So that means I don't actually have, for example, an array of integers or whatever. It's something of type T. So the answer for G is going to be T. So if I'm accessing that T, that three-dimensional array of type T, that means I'm gonna get back something of type T. So therefore at F, I'm gonna say that's T. It's just T, right? Whatever that type is, or that generic type. And then I scroll down E, F, G, and then G. G is also T. So they just try to make you doubt yourself. G is also T. Why is it T here at F? Because look at the three parameters, X, Y, and Z. That means I'm accessing this array. Obviously, this array is going to be of type T, right? So that you can accommodate any type. It can be an array of strings on it that are, okay, you wouldn't say three-dimensional. Yeah, you wouldn't say that, but it can be a string, it can be an int, it can be anything. But it's three-dimensional, right? But then here we are missing that G, which is going to be of type T. But then I don't know what was the significance. I'm trying to understand this here. I'm trying to understand this here. I think this is the answer, not T. So complete this paper B, or they were fighting, they're trying to confuse, in every single way. In which, right, complete the following code in which a generic storage 2D class acts as a container for one-dimensional data of type T. And then they told us that, and then now they're showing us field. That's the part I just don't understand. What they usually put this thing is this class, everything they talk about at the top, it always has relevance. In this scenario, I don't see how is this relevant, because this is clearly a 2D class, right? And here we're dealing with 3D. I can't put it here at G. That's going to be definitely wrong. So I don't know what's the whole significance of this class. Maybe down there we'll see as we go, but I don't see its significance. So let's look at H. So remember, with templated classes, right? In the header file, you declare the you declare how everything is, right? The declaration of functions, everything, right? And then before the end if uh, preprocessor directive, you need to include your imp file, right? Since it cannot compile that code, right? So we need to include it inside the header file. So what's missing here, it's field.imp, and then there it is even here at the bottom. But then what's missing at H, it's field.imp. Is it H? Mm. So it's not T here. What am I doing? Let me see. Yeah, I don't know what I was typing there. That's not H. E, F, G, H. Yeah, we're not there at H yet. What is this here? B, okay. So at H needs to be field.imp. So this is going to be field.imp. And you only put what's missing. Remember, the double quotes are already there. They are not necessary. What's only missing is what goes within the double quotes. As you can see, H is within the double quotes. A, B, C, D, E, F. Oh, I knew something was missing. E, F, G, H, I. Yeah, I knew something was missing. So G is going to be T. Like we talked about, G is going to be T. And then H is going to be field.imp. And then inside the field.imp, we're not done yet. We still have I and J. So inside field.imp, we need to have this, blah, blah, blah. And then I, remember, I is part of, we're just specifying that it's part of field class. But remember, since it's templated, we need to pass that parameter. So the answer here needs to be field of type T, right? Because it's parameterized, right? It's templated. And then J is just constructor chaining. So that's just the colon that's missing there. Because as you can see, we are calling another constructor. So we're doing constructor chaining. So J is just the colon. And then that's pretty much that. I think I should end it here because this goes quite a lot to explain, but then I think I should end it here. I'll just continue from 2.2 going downwards. So see you in the next video.